Physics chapter 17, end of chapters, question number 8. Explain what is meant by a centripetal force. So the definition of a centripetal force is the force acting towards the center of a circle on a body moving around that circle, or the force that is required to keep a body move in a circle, and the force which is always acting towards the center of that circle. So you have to write all of those points. Then part B, a teacher swings a bucket of water of total mass 5.4 kilograms round in a vertical circle of diameter 1.8 meters. Calculate the minimum speed which the bucket must be swung at so that the water remains in the bucket at the top of the circle. So now here, what is the equation that you need to understand? So the minimum force means the weight has to be cancelled out. So the centripetal force needs to cancel out the weight, right? So that means you have to use the equation F equals mv squared upon r and find out what is going to be the velocity at which it has to be rotated. So let's do it. F equals mv squared upon r. Because the F is the cancelling out effect of mg, it is equal to that. Then mg equals mv squared upon r. So now we substitute the values, but before that we actually have some cancellations that we can do. So then v squared is equal to gr. V squared equals gr. So then G is 9.81 multiplied by R is let's find what R is. Diameter 1.8 meters. So diameter 1.8 means it is the radius is 0.9. So then you do this calculation, you will get V squared to be 8.829. Then you find the square root, then V is going to be 2.97. So somewhere meters per second, somewhere around 3 meters per second is the speed at which she will have to swing it to make sure that it does not fall off. The water does not flow out of the bucket. Then part 2, assuming that the speed remains constant, what will be the force on the teacher's hand when the bucket is at the bottom of the circle? So bottom of the circle. So that means this is being this is swung not in a horizontal way, it is vertical circle. Okay, it is vertical circle, so you have to read the question properly. So that means it is at the bottom and at the top, at the two extreme ends of the circle. So now they are asking, assuming that the speed remains constant, what will be the force on the teacher's hand when the bucket is at the bottom of the circle, right? So at bottom you are going to have, the centripetal force is going to be twice mg. Why? 1 mg is cancelling out the effect, the other mg is the weight of the bucket, right? So both of those are going to be acting on her hand. So F equals 2 mg in this particular situation. Let's do it here itself. F equals 2 mg. So then twice m is, what is m here? 5.4. G is 9.81. When you get the final answer, F is going to be 105.9 newtons. That would be the answer. I hope you understood. If you have any questions, please raise them. Let's go to question number 9. In training, military pilots are given various tests. One test puts them in a seat on the end of a large arm, which is then spun round at high speed as shown in figure 17.22. Because they have to actually undergo this severe training, because they have to on spinnings, to escape the fire of the other aircrafts. So if you ever become a pilot, and if there ever was a war, and if you were required to do this, then you might need this. Then also, if you become an astronaut in the future, and if you were ever to go out into the deep space, and if you were to escape or navigate through some asteroid or something like that, then you might want to be trained how to go for spins. So to train these military pilots, there are these they are not asked to train themselves in real life situations, because they might faint. They all faint at the beginning. So to make sure that they don't faint while they are piloting the plane, they are given a lot of training. Now let's answer the questions. Describe what the pilot will feel and relate this to the centripetal force. Now the pilot, if you are actually even in a merry-go-round, you will feel the same thing, right? You will feel that you are going to get thrown out of the circle. You will be getting thrown out of the this particular circle, or you will feel pressed against the wall, right? You will be feeling pressed against the wall. So that means but the problem is the centripetal force. We know that centripetal force is actually the force that is required to keep something in motion in a circle, but it is acting towards the center. Then why is it that the pilot is feeling that he is getting thrown out of the circle? That is because it is the force that pushes him, the force on the wall that pushes him towards the center. That is what he feels at the back of him. He is feeling that he is being pushed against the wall. So that is what he feels from the other end. From from behind, he feels that force, that he is being pushed towards it, and that makes him feel like he is getting thrown out. Then part B. At top speed, the pilot will experience a centripetal force equivalent to 6 times his own weight. That is 6g. We call it 6g, 6 times the gravity, 6 mg. Calculate the speed of the pilot in this test. So it's quite easy in this particular situation. F is equal to mv squared upon r. In this particular situation, the F is equal to 6 mg. F is equal to 6 mg. So let's do that calculation. F equals mv squared upon r. But because F is equal to mg, but the thing that you need to understand is this is 6 mg. F is equal to 6 mg. Then m to m gets cancelled out. They are asking for let's see the question. They are asking for calculate the speed of the pilot in this test. So they are asking for v. Then you get 6r is equal to v squared. 6r equals v squared. Then v is going to be 6r square root. When you substitute the values, you will get the answer to be 17.15 meters per second. 17.15 meters per second. I hope you understood this. Let's go to part 2. Calculate the number of revolutions of the pilot per minute. Calculate the number of revolutions per minute. So now we know we have to actually relate this to omega, the angular velocity. So you find out the angular velocity. Angular velocity is found by the equation omega equals we can find it by the equation omega equals v upon r. So you substitute values here. We know v and we know r. V is 17.15 and r is 5. From that we can get omega to be you get the omega's value, and then you substitute that to find out you will get you will be, once you get omega, you will have to apply that to find out the revolutions per second. So you divide omega by 2 pi. You divide omega by 2 pi, then you will get 0.54 per second. Then you multiply this by 60 to find out per minute. You will get the answer then. Then suggest why it is necessary for pilots to be able to withstand forces of this type. That is because, like I told you earlier, they have to during military real life military fighting or sky battles, they have to experience very high speeds that would they would have to take very sharp turns, and that makes them experience lot of gravity, that is lot of G's. You say that they are experiencing heavy G's. Like now, if you ever become an astronaut, I'm sure you if you really want to be an astronaut, you should work hard and do things that would make you an astronaut. If you do things that would make you a chef and expect you to become an astronaut, or for someone to come and pick you up to be an astronaut, that is not going to happen. You have to do things that would make you an astronaut. You have to you have to write your own life story. It is not up to anyone else, and it is your life you are going to live. So make sure that you do what you want, and also remember that you do what makes you a great person in the future. So if you ever become an astronaut, you will be flying vertically up into the sky in a rocket, and that rocket will experience, because you are flying against the gravity, you at the beginning you will experience huge amount of G. You can actually you can pass out, you will faint because of the heavy gravity that you experience. But if you go hundreds of kilometers up into the sky, you can float about because there is no gravity there. I hope you understood the questions, answers. If you have any more questions, please raise them.